Hello everyone. Today we are going to see the chapter surface area and volume. Right? Exercise 13.2. So here volume of a combination of solids. In the previous exercise we learned surface area of a combination of solids. The thing is there we found the surface area. Here we are going to find the volume. So first you see the figure here. See this base. This base is it in cuboid, right? And the upper part, if you notice, it is half of the cylinder, right? So we have to find the volume of the base, which means the volume of the cuboid plus half of the volume of the cylinder. Then if we add those two volume, we will get the volume of the required figure, right? The next figure, if you notice here, the upper part is like cone, right? And this part, the second part is like hemisphere, right? So we have to find the volume of the conical part plus this hemispherical part. If you add those two volumes, we will get the volume of the whole figure, right? So our exercise, first problem. A solid is in the shape of a cone standing on a hemisphere. See, there is a cone and the cone is standing on a hemisphere. So we are having combination of two figures. One is cone, another one is hemisphere. With both their radii being equal to 1 centimeter, they have given the radius of both is 1 centimeter and height of the cone is equal to its radius. The height is equal to the radius they have given. Find the volume of the solid. We have to find the volume of the figure, right? So here first we will write what are all the things given. So here they have given the radius is equal to 1 centimeter and the radius is equal to height. So height is also 1 centimeter. Now, so we have to find the volume of this figure means volume of the conical part, which means this upper part, and the volume of the hemisphere part. If you add these two, you will get the volume of the full figure. So, volume of the cone is 1 by 3 pi r square h and volume of the hemisphere is 2 by 3 pi r cube, right? So, we are going to substitute 1 by 3 pi r square, r is 1. So, 1 square, right, into 1 plus 2 of 1. What is this? We are adding this. See, 1 by 3 pi r square h plus here what we are having 2 by 3 pi r cube, right? So now if you notice these two terms, what is common in these two terms? 1 by 3 is common. Next, pi is common, right? Next, r square is common, right? R square is common. And write down the remaining thing. 1 by 3 we took it out, pi we took it out, r square also over. What is the remaining thing? H plus. In the 2 by 3 we took 1 by 3 out. So the remaining will be 2, right? Pi we took it as common. In r cube, r square we took. So r will be remaining. Clear? 1 by 3 pi r square we took common. So the remaining thing h plus 2r. So now substitute the value 1 by 3 pi r. R. What is the value of r? 1. So 1 square. Then bracket, right here. What is the value of h? 1 plus 2 into what is the value of r? 1. Clear? This is the substitution. So now we are going to simplify 1 by 3 pi into 1 plus 2 into 1, 3. So this 3 and 3 will get cancelled. So the remaining will be pi only. So it is pi centimeter cube. Right? Easy thing. Nothing we did. We find the we have to find the volume of separate figure. Then we have to add. That's it. This is your first question. We will move on to the second one. Right. And here your second question. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. Okay. See, some student is going to make a model. How the model will be? It will be like it is a cylinder. In that cylinder, the two ends and two cones they are going to attach. The diameter of the model is 3 centimeter. Diameter they have given 3 centimeter. Look at the figure. So the diameter is 3 centimeter and its length is 12 centimeter. So the length is 12 centimeter. If each cone has a height of 2 centimeter, listen, for cone they have given 2 centimeter. Overall height 12, cone only 2 centimeter. Find the volume of air contained in the model that Rachel made. We have to find the volume of this model. Okay. So now height of the cylinder we have to find. Right. Overall height they have given. Listen. This overall height they have given, which means including this cone they have given. We need the height of this particular part only. So what we have to do, this overall height 12 minus, right, height of the cone. What is the height of the cone? 2 centimeter. Two cones are there. This cone 2 centimeter and this 2 centimeter, 2 plus 2 4 centimeter. So see, suppose the overall height is 12. Right, here two cones are there. So this is 2 centimeter, this is 2 centimeter. I want this area, right? What I will do, this 12 minus 2 plus 2 4, what I will get 8 centimeter. That's it, right? So now radius we have to know. See, diameter they have given 3 centimeter. If diameter is 3, what is the radius? Diameter divided by 2, 3 by 2, which is 1.5. Next, height of the cone, we know they have given 2 centimeter. Now we have to find the volume of that model. So what you know what we have to do? We have to find the volume of the cylinder, then volume of the two cones. So now the total volume of the air contained will be, the total volume of that model will be volume of the cylinder, right? This thing, and plus the volume of two cones, because in the upper part one cone is there and the lower part another cone is there. So if you find the volume of two cone plus this cylinder, we will get the overall volume of this model, right? So here we are going to substitute first volume of the cylinder plus, which is pi r squared h, plus 2 into volume of the cone 1 by 3 pi r square h. Okay na? So now here we are substituting the value. We are getting 66 centimeter cube. Okay, 66 centimeter cube. And the third question, a gulab jamun contains sugar syrup up to about 30% of its volume. See, in some container, gulab jamun is there. That sugar syrup is up to about 30% of its volume, right? Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder. That gulab jamun shape is like cylinder, not like round gulab jamun. It is like cylinder. Next, with two hemispherical ends, that gulab jamun's size, precisely they are telling that it is like cylinder that two ends will be like hemisphere. See the figure here. It will be like this. Like length 5 centimeter and diameter 2.8 centimeter. They have given the length and the diameter. Right. So now the gulab jamun shape is cylinder with two hemispherical end that they have mentioned. So now the total height of the gulab jamun they have given, see, listen here. Here they have given length is 5 centimeter. So the height of the gulab jamun is 5 centimeter. Diameter is 2.8 centimeter. So here we have written 2.8 centimeter. If diameter is 2.8, what about the radius? 2.8 divided by 2 will give you 1.4 centimeter. Right. Next thing, the height of the cylindrical part. Height of the cylindrical part. See, cylindrical part only we need. You better you see this figure. Clearly it will be mentioned. See this figure. Okay, na? In this figure, if you see, this is the cylindrical part and this is the hemispherical part. We need the height of this particular cylindrical part. So how we will find? Overall height is 5 centimeter like our previous problem. 5 centimeter and this height 1.4. This is 1.4 and this is 1.4. 1.4 plus 1.4, 2.8. So 5 minus 2.8 will give you 2.2. That is the height of cylindrical part. Right? Excluding these two. Next. Now we have to find the volume of one gulab jamun. So how we will find? Volume of the cylinder plus volume of two hemispheres. See this figure only. This is the figure which is the combination of two figures. One is cylinder, another one is two hemispheres. So we have to find the volume of these two, then we have to add. So volume of the cylinder is pi r square h plus, right, two hemispheres. So 2 into 2, 4. 4 by 3 pi r cube. Now substituting the value and simplifying, we are getting 25.05. This is volume of the gulab jamun. Here in the question what they are telling, the volume of the sugar syrup is 30% of the total volume. 30% of the total volume. Total how many gulab jamuns are there? 45 gulab jamun are there. One gulab jamun volume we found, which is 25.05 centimeter cube. So for 45 gulab jamuns, 45 into 25.05, right? And one more thing, the sugar syrup is 30% of the volume. So 30% means 30 by 100 we can write. After simplifying, we are getting 338.184 centimeter cube. Clear? One extra work we are doing after finding the volume of one gulab jamun. What we are doing? 45 gulab jamuns are there overall. So 45 into 1 gulab jamun volume. After that, they have given that the sugar syrup is 30% of the volume. So 30% means how we can write? 30 by 100. After simplifying, we are getting the answer. Clear? So next question. I will erase this one. Yes. A pen stand made of wood is in the shape of the cuboid. So there is a cuboid with 4 conical depressions to hold the pen. To hold the pen, they are having conical shape depressions. The dimensions of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. The radius of each of the depression is 0.5 centimeter. Depression means that cone shape only they are telling. And the depth means 1.4 they have given. Height only. So we have to find the volume of the wood in the entire stand. In the overall stand, we have to find the volume of the wood. Right? First, here, what are all the figures are there? One is cuboid. Right? Another one is cone. Two things are there. They are asking the volume of the wood. The wood particle volume only they are asking. So first we have to find the volume of the cuboid. So you know the formula, length into breadth into height. So 15 into 10 into 3.5. So we are getting 525. One shape over, which is cuboid over. Next, now they are having cones, right? So cones are there. How many cones are there? 1, 2, 3, 4 cones are there. Okay, now because here they have mentioned 4 conical depressions. So 4 into volume of the cone is 1 by 3 pi r square h. Radius they have given. What is the radius beta? 0.5. Depth means height only 1.4. Substitute everything. We are getting 1.46 centimeters square. Now the question starts. What they are asking, volume of the wood they are asking. See this figure. This is the pen stand. Here if you notice here 1, 2, 3, 4 holes are there. If I am going to fix a pen means, right, the pen tip is in the shape of cone they are telling. I am going to fix in the wood, which means they carved the wood in the shape of cone. So they removed the cone shape from the cuboid, isn't it? Simple ma. See, I am having one cuboid wooden box. In that I am going to place my pen. According to my pen tip, like a cone, what they did, they removed the space from the cuboid. So what we have to do, we have to remove the volume of cone from the volume of cuboid. That's what here. You should not add. Right? Read the question properly and understand the question. Right? That's why figure also they have given. So volume of the cuboid minus volume of cone. 4 cones volume. So we will get the answer. Right? Important question. Fifth question. A vessel is in the form of inverted cone. So it is in the form of inverted cone. Right. Its height is 8 centimeter. Radius of its top, which is open. The top is open. Like funnel, we will, the top is open. Is 5 centimeter radius they have given. It is filled with water up to the brim. See, till here now it is filled with the water they are telling. When lead shots each of, which is a sphere of radius. Lead shots means like sphere. Its radius they have given, which is 0.5 centimeter, are dropped into the vessel. In the vessel now we are dropping. 1/4 of the water flows out. While you are dropping that lead shots, 1/4 of the water is flows out, which means it is coming out. Find the number of lead shots dropped into the vessel. See, nothing. Don't confuse with lead shots and all. You are having a glass that is in the shape of cone. In that you are having some juice or water, whatever liquid it may be. In that you are going to place some stones. You are going to drop some stones. Right? The stone radius they have given. While you are dropping the stone, right, the glass is full of water, obviously it will comes out, it will flows out, right? While you are dropping the lead shots, the stones, 1/4 of the water it is coming out. So what they are asking, what is the volume? Find the number of lead shots, how many stones, how many lead shots you put into the vessel, you dropped into the vessel, they are asking. This is the concept of the question, right? So here, radius, what are all the given things? We will note it down first. So here the radius is 5 centimeter. They are talking about cone first. Next height is 8 centimeter. And the sphere means the lead shot or stones. The radius is 0.5 centimeter. Okay. We have to find the volume of the cone, right? First, volume of the cone is equal to volume of water in the cone. Obviously, the volume of the cone is equal to the volume of the water inside the cone. Suppose I am having a water bottle, 1 liter water bottle, right? So the volume of the water bottle is 1 liter. So how much water I will pour into this? 1 liter only I can. That is what here they have given. So the volume of the cone, the shape of that particular vessel is equal to how much water is inside the vessel. So 1 by 3 pi r square h is equal to, right? So I am substituting and I am getting the value of 200 by 3 pi cube. We will keep the pi as it is. Why we are keeping means while we will do cancellation, that time it will go up. Okay. So next, total volume water flown, overflown. How much water it came out? Okay, na? 1/4 of the water is coming out, they are telling. So 1/4, 1 by 4 into the volume of the vessel or water we found. So 4 ones here, 54s are 200. So 50 by 3 pi. This much water na, while you are dropping the stones or dropping the lead shot, this much water is coming out. Right? So the volume of the lead shot is 4 by 3 pi r cube because it is in the shape of sphere. So what is the formula to find the volume of the sphere? 4 by 3 pi r cube. So while substituting I am getting 1 by 6 pi. Now you know that volume of the particular water and volume of that stone and how much water came out. Everything you know. Right? So here how we are going to find how many you put means how much water fell down divided by the volume of the lead shot. Then you will get how much lead shots you poured, you dropped into the water. Clear? See how many lead shots, how you will find the volume of the water came out. After putting the stone only the water is coming out, isn't it? So total volume of the water overflow divided by volume of the lead shot. So we know that 50 by 3 pi is the water flown out. So 50 by 3 pi divided by volume of lead shot, how much? 1 by 6 pi. Okay? Pi and pi will get cancelled. 50 by 3 into this 1 by 6 will go per means 6 by 1. So now we can divide, we are getting 100. Clear? That's an easy question only. Next is sixth question. A solid iron pole consists of a cylinder of height 220 centimeter and the base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram mass. Right? This is the figure. So what we have to find? Height of the big cylinder. Big cylinder means the base cylinder. They have given height 220 centimeter, radius, they have given the diameter 24 centimeter. So the radius is 12 centimeter. First we have to find the volume of the big cylinder, right? That's why in capital I denoted, which means pi capital R square h. We know R is 12, h is 220. Substitute and find the value of this. So we are getting the value this as the big cylinder volume. Next, for the small cylinder we will find height is 60 centimeter they have given here and radius is 8 centimeter they have given. So substitute pi r square h, we are getting this value. So volume of iron means the volume of big cylinder plus volume of the small cylinder, you will get the volume of the iron. So volume of the big cylinder we know, small cylinder. If you add, this is the volume of that iron. Right? One extra information they have given. What is that? Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram mass. So mass is equal to density into volume. Density multiplied by volume will give you the mass. Okay. So here how we will find 8 into, right? 8 into, here we have found this na. So if you multiply that, we will get 893 approximately. Clear? Next year 7th question is homework. Everything is there, right? Nothing difficult. So you check it out, the 7th question. And 8th one, a spherical glass vessel has a cylindrical neck 8 centimeter. Cylindrical neck. So it is the combination of two things. One is cylinder, another one is spherical part, sphere. Cylinder and sphere, right? First you have to find the volume of the cylinder, then you have to find the volume of the sphere. If you add the total figure, you will get. Clear? Right. So this exercise over. So the next exercise we will see in the next video. Thank you.